section 7.2. It's called rational. We just got done talking about irrational exponents. Rational just means can be written as a fraction. And we know exponents just means power. So most of what we're going to do in this section is just, I have 9 properties of exponents that I'd like to go over with you. Some of them you might remember, some of them you might not, but let's break it down like this. Let's talk about the rules with exponents. And then I'll give you examples to model those rules. First rule is the 0 power property. Anything to the 0 power is 1. So if you had -2 to the 0 power, the answer is just 1. Anytime anything is raised to the 0 power, the answer is 1. Second property is the inverse or the reciprocal property. If you have a negative power, this just means you do 1 over a to the n. Negative exponent just tells you to switch the position. So 3 to the -2 is just 1 over 3 to the 2nd. 1 over 9. Next one is called the product property. If you're multiplying with the same base, A is called base. If you have the same base, what you do is you add the powers. If you had x to the 2nd times x to the 4th, the answer is x to the 6th. If you're dividing the same base, then you subtract their powers. Example would be like x to the 5th divided by x to the -3rd would be what? I'm trying to trick you. What would it be? This would be x to the 5 minus -3, or x to the 8. Right? So subtracting a negative. The property says a power to a power. If we have a power to a power, what we do here is we multiply. So, for example, x to the 2nd to the 3rd would be x to the 6th. You just multiply those powers. We also have power of a product. A to the m, b to the n, all to the x power. You would distribute and multiply these. This would be a to the mx times b to the n. An example would be you had -x to the 3rd, y to the 4th, all to the 2nd power. Using this property, we're going to distribute this to everything. So you just want to be careful with the -2. This is really -2 to the second power, x to the 6th, y to the 8th, or 4x to the 6th, y to the 8th. Make sure you raise that whole number to that power. Next one is power of a quotient. If you had a to the m divided by b to the n all to the x power, similar to what we just did, we distribute that to the exponents. It would be a to the mx over b to the nx. An example would be like, what if we had x to the -2nd over y to the 3rd to the -2nd power. Remember what we just said, you want to distribute. It should be x to the 4th over y to the -6. And we talked about negative exponents. Negative exponents tell you to switch the position. So if you have a negative power in the denominator, we just bring that to the top. The answer would just be x to the 4th, y to the 6th. A couple more properties. We already talked about these. The 8th property says if you have the nth root of a to the m power, that's the same thing as a to the m over n. Also the same thing if you have the nth root of a to the m power, it's the same thing. So 64 to the 2/3. You need to know if you have a fractional exponent, that tells you the radical. So the 3rd root of 64, second, or we could write this, the 3rd root of 64, the second. Which one is easier to do in our heads? Square 64 and take the cubed root, or cube 64 and square that? Yeah, I don't. 64 squared is a huge number, right? I don't know what that is. But what's the cubed root of 64? Square root of 64 is 8. The cubed root of 64 is 4. You could always just use your calculator too. So that would just be 4, and then 4 squared is 16. We're going to do it the other way. There's nothing wrong with that. 64 squared is 4,096. I wouldn't know that. I'd have to use my calculator. If you take the cubed root of that, that would be 16. So you wind up with the same answer no matter which technique you use. And then the last property before we start doing some of these problems is if you take an even root of anything to an even power, and you get an odd power answer, you need absolute value. An example would be like the 4th root of x to the 12th. 12 divided by 4 is 3. But we need absolute value for that because of what we talked about in the last section. So those are all the properties we're going to be using in this section. We'll just go through some examples using those. So let's evaluate each fraction. (64 to the 1/2 power). You have to be able to look at it and just say this is the second root of 64 to the first power. The square root of 64 we know is 8. 8 to the first is just 8. I'm going to go through these kind of quickly because they're kind of like one-step problems. 32 to the 1/5 power is the 5th root of 32 to the first. 5th root of 32 is just 2. The denominator of a fractional power is just the index of the radical. About negative 81 to the 1/4 power. What this means is the opposite of the 4th root of 81 to the first power. That's what the property says. 4th root of 81 is 3. So answer would just be negative 3. Negative 81 to the 1/4 power means we're taking the 4th root of negative 81 to the first. If you remember when we talked about this, if this is even, this can't be negative. So we just say that there's no real solution. Negative 64 to the 1/3 power just means the cubed root of negative 62 to the first. The cubed root of negative 64 is just negative 4. Negative 4 to the first is negative 4. If we have fractions, like 1 over 27 to the 1/3 power, this just means 1 to the 1/3 over 27 to the 1/3, or the cubed root of 1 over the cubed root of 27, which is 1/3. (25 to the 3/2) means the square root of 25 to the 3rd power. 3rd of 25 is 5. 5 to the 3rd is 125. 27 to the 2/3 means the cubed root of 27 to the second power, or 3 to the second power, which is 9. Negative 16 to the 3/2 means negative, as long as it's not in parentheses, that means it's on the outside. So negative square root of 16 to the 3rd power. Square root of 16 is 4. 4 to the 3rd is 64. So negative 64 would be the answer. Negative 64 to the 2/3. This means the cubed root of negative 64 to the second power. It's negative 4 to the second, 16. The last one from this section is negative 36 to the 3/2 power. Means the square root of negative 36 to the 3rd. Can't do this. This is even, and this is negative. We talked about the answer being no real solution. Other types of problems I wanted to go over with you. You could actually just prove this in the same type of example. Call it example L here. We have 81 to the negative 3/4 power. So similarly to what we did before, 3/4 is what we had before, but now we have that negative power. Do we remember what that negative does? It goes to the bottom right. So this is the same thing as 1 over 81 to the 3/4. The negative goes away when you switch the position. So this would be 1 over the 4th root of 81 to the 3rd power. 4th root of 81 is 3. 3 to the 3rd is 27. More with the negative exponent. 36 to the negative 3/2. 1 over 36 to the 3/2. 1 over the square root of 36 to the 3rd power. 6 to the 3rd is 216. We have one more like this. What if it's 64 over 25 to the negative 3/2 power? When you have a negative, that tells you to switch the position. So we're just going to flip this. This is really just 25 over 64 to the 3/2 power. And then we could take the second root of 25 to the third over the second root of 64 to the third. 5 to the third is 125. 4 to 64 is 8 to the third, which is 5 to 12. What if I asked you to write each exponential as a radical? These will be a little bit easier. I'm just asking you to convert it to radical form. So if we had 19 to the 1/2, this just means the second root of 19 to the first. Or most people would just write the square root of 19. That's fine. The 1 is assumed and the 2 is assumed. 11 to the 3/4, which means the fourth root of 11 to the third power. (14) times x to the 2/3. Now the 2/3, is that on the 14 and the x, or is that just on the x? Just the x, right? So the 14 is there just as like a decoy, but then we write the cube root of x to the second power, or 14 times the cube root of x to the second. Either one of these is fine. Similarly, if you had 5 times x to the 3/5 minus 2x in parentheses to the 3/5, this just means 5 times the 5th root of x to the 3rd minus the 5th root of 2x to the 3rd. We're just getting practice using the different properties of radicals. About x to the negative 5/7. We switch the position. Write the 7th root of x to the 5th. And we could either put the 5 inside the radical or we could put it outside. The property says either one is fine. Last one for this type of example would be x to the 3rd plus y to the 3rd to the 1/3 power. this just means the cubed root of x to the third plus y to the third to the first power. You're not allowed to do this. This is wrong. You can only do that if it's multiplication. All right? If it's over addition, you can't do that. Only distribute over multiplication, not addition or subtraction. Three more types of examples here. What about if I wanted to write as a radical? Simplify. Let's say the square root of 37. Have to try to remember what that is. Properties. If this is a 2 for the index and a 1 for the power, 37 and a 1/2. The fourth root of 9 to the 8 is just 9 to the 8 fourth power, or just 9 to the second, or 81. And then the eighth root of z to the 8, z to the 8 over 8, is z to the first. One other thing we have to do with this. We have to evaluate it. Because remember we said if there's an even root of an even power, and we get an odd power answer, we need absolute value. A couple more types of problems, and that'll be it today. Ask you to simplify. Let's say if we had 3 to the 1/2 times 3 to the 1/3. The bases are the same, which means we have to add the powers. This would be 3 to the 1/2 plus 1/3. You guys learned growing up in elementary school how to combine those. You could always use a calculator too. 1/2 is the same thing as 3/6 plus 2/6 is just 5/6. What if we had 7 to the 2/3 divided by 7 to the 4/3? Subtract it. 7 to the 2/3 minus 4/3, which is just negative 2/3, or 1 over 7 to the 2/3 power. Remember, negative power means you switch the position. How about a to the 1/3 times b to the 2/5, the 6th power, all over b to the 2nd. A couple different properties here. be the 6. This would be a 1/3 times 6 is 2. B to the 12/5, all divided by b to the 2nd. And then you subtract the powers of b. This would just be a to the 2nd, b 12/5 minus 10/5. A to the 2nd, b to the 2/5. Remember, if you're dividing bases, you subtract the powers. By a to the 3rd, b to the -4th, divided by a to the -2nd, b to the 1/5, all to the -1/2 power. So we have a whole bunch of properties here. First thing let's do is let's subtract them. So 3 divided by -2, or a to the 3rd divided by a to the -2nd would be a. 3 minus -2 is 5. -4 minus 1/5 is -21/5. What we did is we subtracted the powers. Finisher will just distribute this. The a to the -5/2 times b to the 21/10. We just bring this a to the bottom and write b to the 21/10 over a to the 5/2. What if we had r to the 2/5 times r to the 3/5 plus r to the 8/5? We're just going to have to distribute. So r to the 2/5 times r to the 3/5 plus r to the 2/5 times r to the 8/5. If you're multiplying the same base, you add the exponents. So 2/5 plus 3/5 is 1. 2/5 plus 8/5 is 2. Just in the few minutes or so we have left, I just wanted to do a couple examples here. That's a little bit different. What if we had the 4th root of x to the 3rd times the 5th root of x to the 1st? Sometimes in order to do these more complicated problems, we have to convert them to exponents and then simplify them that way. So the 4th root of x to the 3rd is just x to the 3/4. It should be x to the 1/5. Remember, we add them. Add them, you would just get x to the 19 over 20, or we could write it using radicals, the 20th root of x to the 19. Similarly, if we had the square root of x to the 5th divided by the 3rd root of x, just think about if you could write this another way. this would be the same thing as x to the 5 halves divided by x to the 1/3. And we're just subtracting those. 5 halves minus 1/3. 5 halves minus 1/3 is 13/6. We could write this the 6th root of x to the 13th. And the last example for tonight is what if we had the cubed root of the 6th root of x. Easiest way to do a problem like this is to convert to exponents. So this is really just the cube root of x to the 1/6. And then we're taking the cubed root of that. So this is just x to the 1/6 to the 1/3 power. We're converting radicals to exponents. And what do we do if we have a power to a power? Multiply them. So this would just be 1/3 times 1/6 is 1/18, or the 18th root of x.